Hello and welcome. We're now going to cover Module 9 of this core Python programming course by Mission AI, right? Now, in Module 9, I'm going to cover modules, packages, and libraries, right? In the previous module, we had covered object-oriented programming, and before that, we had also covered functions. And we've seen all the things about variable scope and so on. In this case, I'm going to teach you modules, packages, and libraries, right? And you've heard these words being thrown around interchangeably in a lot of cases, but there's actually like subtle differences between them, right? So we'll deal with them one by one. So let's start with modules. Now, in Python, a module is any file containing Python code and having the .py extension, right? So when you talk about a module, you're basically talking about a Python file, like a standalone Python file. Okay. Now in that file, you can define variables, you can run some top level code, you can define a function, you can define a class, and so on, right? Like for example, let's say we want to create some kind of mathematical module that lets a user access these following features, right? So let's say they want to enter the they want to use the value of pi, right, in a variable called pi, or let's say they want to use some simple functions to calculate, let's say, the square and cube of numbers, right? Or let's say we want to create a new class, like define a new class of which extends from integer, and let's call this printable int, right, where we have a method called get pretty string that returns a nice like message when you print out the string, not just the value, right? So these are all different features that I want, right? Let's say to kind of augment the features that are already there in Python. So what I could do is I could define a module which is nothing but a Python file containing either these variables or these functions or these classes, right? And then I have to put it somewhere, right, so that the user can access it, or so that I can access it in my code. Now I have to put it in one of three locations. Okay, so first thing I would do is I would put all this code in a file called mymathmodule.py. So it's a .py file, and so it qualifies as being a module. Now, where do I need to place this module, right? So one of the first location I could place it is in the current working directory. That is, wherever my source code file is, I could place it in the same directory as that. The second location is in any of the directories in the Python path environment variable, right? And the third location is in Python's default installation directory. So I can place it in any one of these three locations. And what happens is uh, Python automatically picks it up and executes it, right? So this is the order in which Python searches for modules. Like if I'm importing something, first it'll look in the current working directory, then it'll look in the directories in Python path, and then finally it looks in the Python's default installation directory. So I'll take you through this code that's going to be contained in my math module, and then we'll go about actually creating it and importing it and so on, right? So first is I'm creating a variable called pi with the value of pi, right? 3.14, so on. Next, I'm creating two functions that help calculate the square and cube of a number. So the square function returns x to the power of 2, cube function returns x to the power of 3, and then there's a class called printable int, right? And so I've used the class keyword to define this class, and there's basically no uh, superclass provided. So this class is standalone, it does not extend anything. Okay. Now I'm defining this init method, which is the constructor function. It takes one value, which is compulsory, and it sets the value attribute to this input argument, right? Now there's also a function which I've defined called get pretty string, which does not take any arguments. It's accessible through the object, which is an instance of this class. And all I'm returning is the string value of printable int, and I'm converting the value attribute to a string. Okay. And I'm returning that to where it was called. So I have these different, let's say, functionalities present in this block of code, right? And let's say I define it separately, and then it's up to me to just import it once in a very convenient way by placing this Python file in one of these three locations. Now, just for simplicity's sake, I'm going to put it in the current working directory. Okay. So I have this directory here, right, which contains my different IPython notebooks. So I'm going to create. So this is basically my current working directory, and I need to place this mymathmodule.py in this directory. So let me copy this code first, right? Instead of writing it from scratch, I'm going to copy this code. I'm going to go to this directory. I'm going to right click, create a new file, let's say a text document, and I'm going to call it my math module.py, right? So I've created my math module.py. Now if I open it, I'll just paste this code inside, right? And I've told you in the first lesson itself, you can use Notepad to write quick code that does not require like fancy editor functions. This is a classic case of it. So I've created this in Notepad. I've saved it in my current working directory, and now it's available for me to use, right? But it's not a part of Python's like built-in functionality. It's some additional functionality that I defined. So I need to import it explicitly. So if I go back here to my Jupyter notebook, right? So how do I actually use this module that I created? So I would use the import statement, right? Which we've spoken about earlier. Like you saw in the case of the reduce function in module 6, it wasn't a part of like it wasn't available out of box. I had to import the functools library or package and use reduce from within that. So in this case, I'll just say import my math module. Okay. Now, when I say import my math module, all its functions, classes, variables are imported. And whatever top level code is there, that's also run. Okay. So I'll say import my math module, and then how I would access the things within that module is I would say my math module.py, which is the variable we defined, my math module.square, which is a square function that returns the square of 9 in this case. I would say my math module.cube, which returns the cube of 4. Then I would say I would create a new object of the type printable int, which is a class I've also defined in my math module. It takes one input to the constructor, which I've shown you. And so now I is an object of type printable int, right? So I can just say I dot get pretty string, and that returns this nicely formatted string with the printable int value. Okay. So I could like just run this code directly, and I can show you how it runs. Let me run it here. I'll just say run. And you can see that it successfully imported my math module, and it's successfully accessing the variables inside here, right? So there's pi, there's square, there's cube, and there's this printable int class. So that's how you import a module and use it in your code, right? Now that's just the basic way of doing it. Now my math module, it's a slightly long name, right? Instead of keeping on typing it out again and again and again, I can give it a different name, which is called an alias, right? So I can say import my math module as M. Okay. So now instead of typing my math module dot py, my math module dot square, I could just say m dot py, m dot square. Okay. So that makes it much easier to actually write your code. And you would have seen this a lot in some of the like the Python code that you would have seen online, like you would have seen NumPy pandas. So import NumPy as NP, import pandas as PD, import matplotlib.pyplot as PLT. You would have seen all these conventions used across the board, right? So here I'm just finding a really simple way to use this math module without typing out the entire name again by using an alias, that is the as keyword. Cool. So we've covered how to import the module. We've covered how to import it using an alias. Now we can use this from keyword to import specific parts of the module. Okay, now let's say I have a ginormous module that has like hundreds or thousands of lines of code, right? And if I import the entire module, it slows down the execution of my function, right? or my code. So instead of taking the entire module and importing it, I can just import specific parts of the module, right? Like for example, if I just want to import the pi variable, I can. If I just want to import the square function, I can. If I just want to import cube, I can, right? So there's two advantages to this. One of them is the fact that I only get what I want, so I'm not overloading the memory requirements here. And on the second side, I don't even need to type module name dot variable name or module name dot function name. I can use these variables and functions and classes directly. Like I don't need to do an m dot whatever or my math module dot whatever, right? So now because from this math module, I've explicitly imported each of these different objects. Now I can just say print pi, print square of 9, print cube of 4. So there's no m dot, there's no my math module dot, right? So I'm just using these objects directly. Okay. Another way of doing it would have been from my math module import star, right? So this particular function here, I could have used this particular line of code. I could have also used this, but the first problem, which is that everything gets imported, not just what we want, that's a problem we'll encounter. So if I copy this here, let me paste it here, right? So now in the first case, I'm just importing, I'm saying from this module, which is the Python file that we just defined, where we defined all these different things. I'm saying from this module, import these specific things, right? And then I'm referring to all of these things directly in my subsequent code. So if I run it here, I get all these things and this code runs just fine, right? Another way here would have been I comment out that and I say from my math module import star, right? So the only benefit here is that I can refer to all the objects inside my math module directly by name without needing to prefix the module name dot. Okay. But the downside is that it imports everything, even stuff that you don't need. So if I run it here, I get the same output, right? It runs fine. But I have imported everything. So if I had 1,000 other lines of code, it would have also imported all those other variables and classes and functions. Cool. So we've seen how to define a module, that is a .py file. We've seen where to place it, that is preferably in the current working directory or in any directory in the Python path variable, right? And finally in Python's default installation folder. Cool. So we've seen how to import the module without using an alias, and then we have to type out the entire module name as a prefix and then dot whatever next, right? Then we can use an alias to shorten the module name, but we still have to use the prefix, right? The alias as the prefix m.py, for example. Then we've seen how to import exactly what we need from the module using the from and import keywords. And we've also seen from module import star, right? So that way we can refer to the name directly. And let's say I've already imported my module here, right? So if I want to see all the variables, classes, and functions available as part of it, I just need to use the dir function on that module name. And if I want detailed documentation, I can use the help function on that module name. But if I have not already imported this, right, then I should pass the module name with double quotes to the help function. So this way help knows that I want detailed documentation on this module, but this module is not already imported. So take the appropriate steps to get the information about that module. So over here, I had already imported my math module, right? And now I'm just going to list out, let's say, I'm going to say print dir of my math module, print help of my math module. So I'll just run the dir command first. And you can see that all these different things are loaded from that module, right? There's cube, there's pi, there's square, there's printable int, and there's all these standard things that get added to any module, right? One of these things being dot name, which is a special variable that we'll see further down. Now, if I comment out that line and I uncomment the next line and I print the output of the help function, then I can see that there is this variable pi There is a class printable int. Under functions, there's cube and square. Under data, there's pi. And the file itself is at this location. So you get the entire documentation about the MyMath module that we just defined. Okay. So it's very simple, right? A module is a simple Python file which contains whatever you want it to contain. So all your helper functions, all these utilities, you can define them in modules. So let's do an exercise now. Create a module called supermath module, right, containing the following objects. So the first thing is the variables e and golden ratios with these respective values. A function that takes two numbers and returns true if the first is divisible by the second. A new type of string where the plus operator returns the sum of the lengths of the strings. Import this module. Okay, so first I'm going to define the module, then I'm going to import this module, right? So here I'll say I'm going to define this module. So I need to call it supermath module, right? So let me just copy this name, go here. I'm going to create a new text file and I'm going to call it supermathmodule.py, right? It has to have a .py extension. So I'll say enter. Yes. I'm going to open this file and I'm going to write a little bit of code inside, right? What's the first thing I need to do? I need to put the variables e and golden underscore ratio with these values. So I'm going to create two variables, e equal to 2.718, golden underscore ratio equal to 1.618, right? So these are the two variables I define. Now I have a function that takes two numbers, returns true if first is divisible by the second. So I'll say define the divisible function that takes two variables, right? v1 comma v2, and it returns true if v1 is divisible by v2. So I can say return v1 mod v2 equal to 0. The output of this condition is a boolean. If it's true, it returns true. If it's false, it returns false to wherever the function was called from. Okay, and over here, uh, I remember telling you that the code inside a function has to be indented, right, by a tab of four spaces. So I'm just making sure there's four spaces here. Now, because it's Notepad, it behaves a little different from your usual Python editors, right? 1, 2, 3, 4. That's what I have. Yeah. Now I have a new type of string, right? So that's basically a class where the plus operator returns the sum of the lengths of the strings. So I'm going to say class new string, right? And it does not extend anything. So it's a standalone class. Now in that class, I'm going to define the init function, which is the constructor. And that takes self as a value, and it also takes a string value, right, as an argument. So over here, I'm going to say self dot value equal to the string value argument which we pass to the constructor. So that's my constructor function, right? Now, as part of this unique behavior, I'm going to define a second function. And what am I doing? I'm overriding what the plus operator does for this object, right? So I'm defining a function with the name underscore add, right? Which is like a predefined function in let's say string objects, right? But I'm kind of redefining what it means for the plus operator. So it takes two things, right? So first, when I say plus, uh, there's already the current value plus, and what is the other value, right? So other is the other new string object that I'm creating. So when I say new string object 1 plus new string object 2, uh, the other is the name of the object containing new string value 2. Okay, so here I'm saying return len of self dot value, which is the instance attribute, right? Plus len of other dot value. So length of this string plus the length of the other string that is passed to this operator, the plus operator, right? So I have my new string class defined, which does exactly what I want. I have my divisible function defined, and I have these two variables defined, and they're part of my super math module, right? So I'm going to save this now, and it's been saved. I'm going to close it, and as you know, I had uh, placed it in the current working directory, so it's already accessible, right? That's one of the three approved locations. So this is done. And now I'm going to do this part, right? Import this module using from, import, and as keywords together, and use each of the imported objects in a calculation and print out the values. So I'll say from supermath underscore module import I'm going to say e golden ratio and uh, divisible and this other class, right? Which is new string. So I'm going to say from supermath module import e comma golden underscore ratio as gr, then just divisible as it is, and what else? New string as ns. Okay, so I'm going to import these things first from the supermath module, and then I'm going to use each of them in a some kind of calculation. So I'll say print e plus gr, right? And I can refer to gr as the golden ratio variable as gr because I've given it an alias. What is the issue here? Inconsistent use of tabs and spaces in indentation. Oh boy. Okay. So um, 1 2 3 4 1 2 3 4, right? This is one disadvantage you will find uh, while using Notepad, because this indentation thing is a little crazy, right? So if I run it again here, it says invalid syntax. Looks like I've forgotten a colon. Here we go. Running it again, we get the right answer here, right? That's the variable e plus the variable gr. So I've used from, I've used I've used import, and I've used as and when required. Now let me do some other calculations. Say divisible of 16 comma 8, right? So it sends true because 16 is divisible by 8. Now if I do 16 divisible by 9, it should return false. That's correct. And finally ns, right? So I'll say ns1 equal to ns, which new string I'm now calling ns, right? Ns of, and I'm passing a string value to it, test string 1. ns2 equal to ns of test string 2. I'm going to print ns1 plus ns2. Now, if I just had these two strings as normal strings, it would have concatenated these two things. But because I redefined what plus means in that new string class, it'll give me the lengths of the two strings added up, right? It's 26 because each of these strings has a length of 13. So 13 plus 13 gives me 26. So I've imported what I defined. I've given it custom aliases where required. And then I've used it directly in this function because I imported them using the from module import variable convention, right? So you've seen how to define a module. You've seen how to create variables, functions, as well as classes in the module. You've seen how to import that module into your existing code, and you've seen how to refer to the variables using either the existing names, their original names, or their aliases. Cool. So let's move on to packages and libraries now. Okay. So uh, now a module is a single Python file, right, with the .py extension. Now a package or a library, these are used interchangeably. Okay. So remember, package equal to library. So don't think more about it. Now, a package is nothing but a hierarchical file structure that contains related modules. Okay, like related modules and sub packages. So, if you think about any folder in Windows or any folder in any operating system, right? So, you'll have a folder, you'll have some files, you'll have an inner folder which also contains some more files, and that's exactly what a package is. Okay, so you have the only constraint here is that these modules should be related to each other in some way. Like if you're saying, uh, let's take for example the NumPy package, right? Now NumPy has a whole bunch of modules that provide functions and objects related to numerical computing. So they're all related to each other, right? So that's the best way to kind of understand what a package is. You have a whole bunch of related modules placed in some hierarchical directory structure. And that directory structure serves as a namespace, right? So the way you access it is top level directory dot second level directory dot third level directory dot module, right? Or whatever the case might be for your case. At every directory level of the package, now here's another very important thing to remember. There should be an init.py file, okay? And this init having a prefix and suffix as double underscore. So this is a special type of file, and it's okay in our case if the file is empty. But typically what this file is used for is to contain all the import statements for the objects in the module, right? So if I were to be importing a whole bunch of different packages within my module, I would typically move those import statements to the init.py file so that there is like a centralized location where this importing happens. And as the name suggests, the init.py would get executed first or be brought into the namespace first, followed by the module, right? Remember that the search path for modules and packages is the same. Okay, so the order is the same. I told you first is current working directory, next is all the directories in the Python path variable, and third is Python's default installation directory. So now what we're going to do is we're going to create this structure and see what exactly packages, sub packages, modules are and how they're related to one another. So I'm going to create a module called my modules, right? A directory called my modules in CWD, which is current working directory. This is the package name. So the package I'm creating is called my modules. Okay. Now under that, I told you at every level of the directory structure, there should be an init.py file. In our case, we can keep it empty, but the file is required to be present. Okay. Now at that first level, I also have this myMathModule.py, which we had defined in the previous bunch of exercises, right? So I'll have that at level 1 along with init.py, right? And at level 1, I have another folder, like an inner folder called supermath, right? And the supermath folder contains two additional files. The init.py, which I told you is required under every folder, and the supermath module.py, which we defined in our previous exercise over here, right? Supermath module. So I'm going to kind of create this dictionary structure, this directory structure, and I'm going to now use this package and all the modules under that package and in the sub packages and import them into my program, right? So if you like, I want you to keep a view of this at all times while we do these different things, right? So if I want to get the my math module from the my modules package, so my modules is the package. Under it at level 1 is the myMathModule.py module. So I would say from my modules, which is the top level package name, import myMathModule, which is at level 1, right? Now, what if I want to get the individual objects from my math module. So I would say from package name dot my math module, I would import these objects one by one by one. Or I would say from my modules dot my math module import star, which imports all the objects in my math module. So the way you access each successive layer or level of the directory structure is by appending these top level names first. So you say level 1 name is my module, level 2 name is my math module, and under that come all the variables, functions, and classes, right? Now, what if I were to look at supermath, right? From my modules.supermath, which is now, this is the main package, this is the sub package because it's another folder in itself, right? So from this sub package, I'm saying import supermath module, which is this Python file in the supermath folder. So how I'm accessing the supermath sub package is by saying package name dot sub package folder name, right? That takes me into this level of the directory, and from here I get the supermath underscore module Python file, right? Now, if I want to get all the objects inside this, I would say my module dot supermath subpackage dot supermath module, and then I would say import star from there. Okay. So also just know that when we import any package, Python like searches all the subdirectories and subpackages also. Okay. So it's not just that level 1 comes in, it's the entire directory structure that is brought in. And we've heard of something called frameworks, right? A frame. So if you think about module being at the base level, one level above that module is your package slash library. One level above that is your framework, right? Framework is a collection of packages and libraries which contain utilities that like let you do something specific, right? For example, Django is a web framework, right? It contains all the different packages and libraries that help you build a Python server and like handle API requests, host content, and so on, right? So level 0 is module, level 1 is package library, level 2 is framework, okay? And at each level, you're kind of like providing a larger offering. So a package is made up of modules and a framework is made up of packages. So first I'm going to create this structure and do that, like execute whatever I wanted to do here in this code. And then I'm going to look at what the exercises are, right? So let's create this directory structure. Now, these modules are already created, but they're in the current working directory. Now, I need to move them to this new directory that I create. So I'm going to say new folder, right? And I'm going to call it, what do I call it? I call it my modules. So I'll call it my underscore modules, right? So that's the name of my package. Now, at level 1 of that package is my math module, the init.py empty file, and an additional folder called supermath. So let me recreate that. I'm going to copy my math module and I'm going to paste it. Actually, let me just cut it and paste it here, right? So that's the first file that I have. Now the second file that I have is underscore init underscore dot py file, right? Which I told you is required at every level of the directory structure of the package. Now, if I open that file, it's empty and I'll keep it empty. And the third thing that I had is a subdirectory called supermath. So if you look here, I've recreated level 1 correctly, right? I have three things. Now in level 2, that is inside the supermath folder, I have init.py and the supermath module.py, which we defined earlier. So let me go back to the previous level. I'll take the supermath module and I'm going to put it inside the supermath subdirectory, right? And the other thing I need here is a copy of this init.py file, which I'm copying because it's empty. But if I had some custom import statements over here, I would move those import statements to the init.py file. So now if you look at it, in the current working directory, I have a folder called my modules, which is my package. At level 1, I have two Python files, one of which is init and is compulsory. The other one is my math module, which we defined in the previous exercise. The third is a subdirectory called supermath, right, which also contains the init.py compulsory file and the supermath module, which we created in the exercise of the previous section. Cool. So I have my directory structure created. Now I can import and use whatever I want, right? So let's just confirm that in our code. So I'm going to say import my math module as an entire module, right? And where is my math module? It's inside the top level package. So I'm going to say import my modules dot my math module, right? So my modules dot my math module. So I'm going in the level of the directory structure, in the order of the directory structure to import stuff. So I'm saying import my math module, right? So I can now use whatever is in the math module. If I'm not mistaken, one of the things was the variable pi, right? Pi, which has the value 3.14. So I'm going to say print my math module dot pi. So if I run it, I get the value of pi. So pi has been imported correctly. So what's the next thing I have to do? I have to import all the objects inside the supermath module, right? Now supermath is the subdirectory under the my modules package, which contains the supermath module. So it wants me to import all the objects inside the supermath module. So I'll say import my modules, which is a package, dot supermath, which is the subdirectory, right? And then I'm going to say dot supermath underscore module, which is the module itself. And I want to import all the objects from inside there. So I'll say from this particular sub package or this particular module, import star, right? So now I can use them directly by name without having to refer to this entire directory structure. One of the variables we got from there was the variable e. So let me confirm. There we go. I can use e directly because I've imported everything literally from top level package dot sub package dot module. Use each of the imported objects in a calculation and print out the values. So to use the math module, I would say print, what are the other things? Square and cube, right? So let me use an alias over here. So my math module as mmm, okay? So I'm going to say mmm.py, mmm.square of 5, print mmm dot cube of 7. Okay, and for this one I'm going to say print golden underscore ratio, print divisible 25 comma 10. So is 25 divisible by 10? And it's, so I get exactly what I wanted, right? All these different objects, pi, square, cube, which is these three things, and e, golden ratio, and divisible, which is these three things. So I've used all these different variables, functions, and classes from the different modules that I've imported. And I've shown you how you can refer to them either using an alias or directly by importing everything explicitly. Okay, so that brings us to the end of packages and libraries. Just to reiterate, the module contains Python code, it has a .py extension. One level higher than that is this container called packages, which is nothing but a directory structure, right? So a package contains at each level of the directory structure an init.py file, like for example here and here, right? It can contain modules, it can contain sub packages, which are nothing but folders, and the sub package will have its own directory structure. So you need to go level by level to traverse this directory structure. So you can say my modules dot supermath module. Okay. So just practice these exercises on your own, create this directory structure and see how uh, you're able to access the functions, variables, and classes within each of these modules. Okay, so moving on to the third section now. Here I'm going to talk about variable scope. Okay, so if you remember, as part of our uh, function module, I told you about this order called LEGB, right, which is local, enclosing, global, and built-ins. So we won't go that detailed right now, but as of now, we'll just look at local versus global, right? So if, for example, I'm within a function, what is local scope? What is global scope? If I'm in outside the function, what is local scope? What is global scope? And so on, right? So if you remember, uh, Python, the order in which it looks for things is first is local, then is enclosing, then is global, then is built-ins. So I have a function here where I have a variable x, right? And I have another variable x in global scope. I'm going to print x first, which is this value. Then I'm going to run the change x function, which changes x to this value. And then I'm going to print it out again, right? But what happens if I do this? I get the same value of x in both cases. Okay, so if I run this here, you might be tempted to think that x now gets changed to 15, but that's not what happens. What Python does is it creates a new variable here in local scope with the value 15, right? And the global scope variable x stays the same. So I should get 10 printed in both cases, which is exactly what happens. Now, how would I actually change the global variable, right? So if I want to change this same x from global scope inside the function, how would I do it? I would first have to bring in the global variable using the global keyword, right? Global x. So what I'm telling Python to now do is bring this variable from global scope into this local scope for edit access. So now that it's there available, I can say x equal to 15. So if I print x now outside after calling the function, it should have the new value 15. So if I run it, in the first case it was 10, now it's 15. Okay, so if I had defined x in local scope and just assigned it a value, that value would not reflect in global scope. But now because I've used the global keyword and brought that global variable x into the function, I can now change its value and it gets reflected in the global variable. That's exactly what we see over here. Okay. Now, basically at any point, right, I can call two functions, locals and globals, to figure out what are the variables and their values in the local namespace and in the global namespace. Okay. So what locals will do is it will return a dictionary containing the names of the variables and the values of the variables in local scope, and globals returns a dictionary containing the names and values of the variables in global scope. So let me run this particular code and show you what happens. Okay, so I have all this stuff here which is in global scope. This function is also defined in global scope, so it's accessible here. But what's inside the function is in local scope, right? So when I'm inside the function, whatever's here is in local scope, and whatever's outside here is in global scope. So let's say I'm looking outside here first, okay? I have the value x equal to 10, right? Then I run change x, and here you can see that the global keyword is not there. So what happens? The global value of x does not change, just the local value of x changes, right? And then I'm printing from outside the function, that is from the global scope, I'm printing what is the local value of x, right? And I'm calling the locals function. And in the dictionary that is returned, I'm looking for the entry with valuable x because with value x because that's the name of the variable. And then I'm converting that into a string. So from inside the function, I'm doing the same thing, right? I'm calling locals. So if I call locals from inside here, it gives me whatever is local over here. If I call locals from outside here, it gives me whatever is local outside here. So local means anything that's available around me at this point, right? I told you scope basically means area of operation. So if I say local scope, it means whatever is active inside over here. If I say local scope over here, it means whatever is active outside over here. But if I call globals from inside, it shows me all the values from outside, right? Locals from inside will give me all the values from inside the function. Globals from inside will give me all the values from outside the function. Okay, so let me run it and show you what happens. So first, I'm running it here. I have the global variable called x with value 10, right? Now I call this change x function. Now what, because I have not used the global keyword inside, it's creating a local variable with value x equal to 15. So the global x has a value 10, local x has a value 15. First, it prints from inside the function, which is what we get over here, right? The next thing it prints is the local value of x, which I've got using the locals function, and then the dictionary entry with key value x. So the local x is 15, right? Because I'd initialized a local copy of x with the value 15. Similarly, the global value of x is the value from outside because the local value is the value from inside. Okay. So the global value of x is 10, which I had defined outside over here, right? And here outside, I can print x, which is 10. I can print from outside the function, which is basically saying global scope. And now I call the local value of x, but from the outside, which basically has the value 10, right? So remember one thing, when I call local, I'm talking about what is around me at this point. So if I call local from inside the function, then the scope is whatever is inside the function. If I call local from outside the function, it's basically whatever is in global scope. So we've seen what locals does, we've seen what globals does, and we've seen what local versus global means, right? So let's do an exercise now, right? Let's define two variables x and y with these values in the global scope. So I'll say x equal to alpha, y equal to beta, and this is in the global scope. Now define a function, let's say def function that has variable y with the value gamma, y equal to gamma. Okay. Now in the function, so this is a local copy, right? This is the global copy. This is the local copy. In the function, change the value of the global variable x to delta and the local variable y to phi phi. So how do I get the global variable x inside here? I say global x, right? And now I say x equal to delta. So from the original value alpha, it will now get changed to delta. And the local variable y to phi phi. Print out the result of globals and locals for the variables x and y, both from outside and inside. Okay. So now I'm going to say print inside func. Okay. Print. How do I get the value of local x? Local x. And I'm going to say plus the string value of the locals function, and within the dictionary that is returned, I want the variable x. Okay. Similarly, local y is plus string value of locals and the dictionary value of y inside that return value. Similarly, I can say print global x plus string of, now instead of locals, I'm going to call globals, right? That gives me a dictionary containing key value pairs of all the global variables. And I'm going to pass x here. And I'm just going to copy this and I'm going to do the same thing for globals y. Change that to y and say global value of y, right? So this is from within the function. Now in the global scope, what I'm going to do is, let me just move this here, right? And now I'm going to say in global scope, I'm going to do the same things. I'm going to make sure there's no wrong indentation. So I'm going to do the exact same thing inside and outside. I'm going to say print outside func, right? So let's run this and see what we get. Oh, sorry, I didn't call the inside function itself. So I'm going to say call the function. What is the name? Func, right? So func, and then I'm going to do this outside processing. So first I define these values in outside global scope. Then I call the function. So the function basically maintains a local copy of y, and it has changed the global copy of x, right? And it's printed out all these values using locals and globals. And after calling function, then I do the same thing in the global scope. So now if I run it, oh, there was an error. Key error x. So if you see what happened here is I brought in this variable x from the global namespace into here to edit it. But there is no local variable called x. It's still the global variable, right? So there is basically no entry in locals that returns the value x. So I'm going to comment this out, right? There is only a local copy of y and also a global copy of x and y. So if I run it now, I'm inside the function, right, which gets called over here. Now inside the function, it's already told me there's no local copy of x. There is a local copy of y, right, which has the value 5, which is here. There is a global value of x, right, which is delta. Even though I defined it as alpha, I had changed that same global value to delta inside the function before calling globals. And what is the global value of y? Beta, right, which is here. There is a local copy of y which is 5, which gets printed here, but the global value is beta. And then it comes outside the function back to the global scope, and let's see what the local and global values are. So local x and global x are the same. Local y and global y are the same. Now why did that happen, right? It's because in this outside scope, what is local and what is global is the same. Okay. Inside this function, what is local is one level below what is global, right? Because the function has a separate scope. But on the outside, what is local is what is global. So locals and globals return the same thing. But on the inside, locals and globals return different things. So you've basically understood scopes, right? Local scope is different from global scope inside a function or inside a class and so on. Local scope is the same as global scope when you're calling locals and globals outside the functions. And the function you're using to get these values and these variables is the locals built-in function and the globals built-in function, which both return dictionaries, right? And how do you get a particular key value from that dictionary? You say dictionary of X, which looks for a variable whose name is X and returns the value of that variable. Cool. So we've seen what are modules, we've seen what are packages and libraries, we've seen what is variable scope at a brief level, and we've also seen the locals and globals functions. And now finally, we're going to look at this one little piece of code that we keep encountering all over the place. Okay, it's the name variable, and we always see if name equals main, right? Then execute something. So what does this mean exactly, right? Now, the Python interpreter creates this special variable called name with double underscore prefix and suffix. Okay. The moment it starts executing a program, this name variable gets set, right? And the value of it is basically what is getting executed right now, right? Like what module is getting executed right now, and that's what is assigned to this name variable. Now, if we're in the, like for example, let's say we run, there is only one Python file, right? Let's say it's file one. Now we say Python file1.py, right? So if we say print underscore name inside this Python file, we'll get the value main because that is the main program being executed. Okay. But if file one imported a file two, then inside file two, uh, you're not going to see the name main. You're going to see the name file two because file two is a module that is being imported. Okay. So the value of the name variable is main only if that is the program that is directly executed. Okay. If something was imported, then the name variable will basically contain the name of that module and it will not be main because main is only assigned to the module which was the main program, the main.py file. So let's say I'm going to create two files, okay, file 1 and file 2. Now in file 1, I'm importing file 2, right? And what I'm also doing is I'm printing out the value of the name variable in file 1, and I'm going to say if that name is main, then I'm going to say file 1 was executed directly. If it's not main, then file 1 was imported. So you see what's happening, right? If I say Python file1.py, then the main program is file 1, right? The main module is file 1. So inside that module, the name variable has the value main, okay? However, if I say Python file3.py, which imported file1.py, then the value would not be main, it would be just file 1. Similarly, I'm having a file 2 over here, right? A file2.py, which is going to be imported into file 1 over here. So in this file 2, I'm going to print out the value of the name variable, and I'm also going to check if it's equal to main. I'll say file 2 was executed directly, else it was imported, right? So let me create this code in two separate files and show you what happens. So back to my directory here. Now I'm going to create a new file, right? And I'm going to call it file underscore one.py. And I'm going to paste the code I had written, right? Where the first statement is an import statement. And after that, I'm printing out the value of the name variable. And I'm also saying if that value is main, then I had executed it directly, else I had imported it and used it. Now I'm going to create a second file where I copy the code for file 2, right? I'm going to create the second file over here. File underscore 2.py. And over here, I'm going to paste the code for file 2. Here, there's no import statement. There's just printing out the value of the name variable and checking if it's main or not. So you can see that if I had executed file2 directly, saying python file2.py, then this code block would have been executed, else this code block would have been executed. Okay, so let me run it now. What I'm going to do is I'm going to open a command prompt, right? I'm going to navigate to the folder where this is present. So under desktop, there's Python programming dot mission AI courses live slash course one. Okay, so I'm in this folder now, right? And I've got my file1 and file2 present. So if I say Python file underscore one dot py and I run it, then what is the main program? It's file1.py, right? So within file1.py, these messages run. That is, the name is main and file1 was executed directly. But what I did first was I'd imported file2. So whatever was in the top level code in file2 gets executed, right? Now in file2, the name variable is file2 and not main. Okay. So the if code that gets executed is the one that prints file2 was imported. So remember this particular output, right? Within the imported module, the name variable has the value of that imported module. And within the main module, that is the direct program being executed, the name variable has the value main. Okay. So now if I do Python file underscore 2.py, now in the py file underscore 2.py file, the value of name becomes main. So you can see that in file2, the value of name becomes main and file2 was executed directly. So basically name is a special variable, right? Name is a special variable that gets set by the Python runtime. So if the file that we are currently in is the file that was directly executed using the Python command, then the value of name is main. Otherwise, it's just the name of the module. So we've recreated this and seen the outputs. It's done, right? Cool. So that brings us to the end of this particular video for module 9, right? We've seen what is a module. We've seen what is a package or library. We've seen how to use globals and locals function to get variables in the local and global scope. And we've seen the name special variable where the value of that variable is main if uh, we are in the module that is directly executed using the Python command. And if we are in a module that is imported, the name is just the name of the module. Okay. Now in the next video, we're going to look at some of the most common modules in the Python standard library, like math, statistics, random, uh, OS, sys, and so on. Okay. So I'll see you in that video. Take care.